All right, let's just dive right in. Welcome to This Explainer. Today, we're tackling a concept that is literally everywhere in pop culture right now. We're talking about the multiverse explained. But look, we're going to strip away all the sci-fi movie tropes, the fog, all that Hollywood confusion, so we can really understand the actual, very real scientific boundary of what we call the multiverse. Our goal here today is to build a solid foundational mental model of what this concept actually means in the world of physics, why serious scientists give it the time of day, and exactly where hard science ends and pure speculation begins. To get us started, I want to ask you a core question. This sits at the absolute heart of the whole multiverse debate. Are we seeing the whole reality, or are we only seeing one tiny visible patch of it? Because, this isn't just about whether the multiverse is a cool idea for a comic book. It sits right on the edge between the physics we can actively test in a lab and ideas that might just be fundamentally bigger than what our current tools can even measure.
There's actually this brilliant analogy for this exact tension. Think of it like standing near Clifton Beach at night, and you're trying to understand the overall shape of the sea from just one small patch of water. You can see the waves immediately in front of you, right? You can see them crashing, you can see their movement, but you can't see the entire ocean all at once in the dark. In that exact same way, our universe, like literally everything we can observe with our most powerful telescopes, might just be that one small visible patch of water in a vastly larger, unseen structure.
So let's move on to our first main area, reality, rules, and possibilities. We're going to open up our intellectual toolkit here because if we want to understand the multiverse without getting totally lost in science fiction, we absolutely have to separate these three concepts. Blending them together, that's honestly where like 90% of the public confusion comes from. Okay, so here they are. First, reality. This is simply what exists. Second, rules. This is how that reality behaves. And third, possibilities. What could exist if the rules allow it? And what's so vital to remember here is that these are not the same thing. Actually, let me emphasize that. Something can absolutely be logically possible without being physically visible to us. And, rules can exist and operate perfectly fine, even when we can only see their secondary effects. So the crucial takeaway here is this. Limited access is not the same as limited reality. Think about being inside a massive building. If you're standing in just one room, you can really only inspect that specific room directly. But just because you can't see the other rooms or the hallways or the other floors, well, that doesn't automatically prove they don't exist, right? It just means your access is limited. When physicists discuss the multiverse, they aren't declaring, hey, we know for a fact there are many universes. They're asking, hey, could the structure of reality just be larger than the room we're currently standing in? Now, let's talk about the rules for a second. In any system, rules don't just control behavior, they define what kinds of outcomes are even possible in the first place. It's kind of like a game of chess. The rules dictate that a bishop moves diagonally, and those exact same rules forbid it from moving like a knight. If you tweak those rules even slightly, you change the entire universe of possible games. You can also think of it like a pressure cooker. The same basic machine can create vastly different meals depending on the ingredients and the heat. The cooker doesn't need to specifically try to create each dish. In physics, if reality is generated by a rule-based system, a single underlying framework could naturally produce an enormous range of different universes as completely natural outcomes. But of course, possibility is not the same thing as evidence. We need to break this down into three distinct levels. Level 1 is logical possibility, meaning it simply doesn't contradict itself. Level 2 is physical possibility. It could actually fit the known laws of nature. And level 3 is evidence, meaning we actually have measurable traces or effects we can point to. Now, the multiverse mostly lives very comfortably in those first two levels. And this, right here, is exactly why scientists remain super cautious until we can hit that third level of hard evidence. It's a lot like hearing a sudden noise from the next room. Your brain instantly generates possibilities, right? Someone is in there, or maybe the wind moved the window, maybe the house is just settling, or something fell off a shelf. Some of these are way more plausible than others. But until you actually walk into that room and check, you don't know for a fact. The human mind can generate physical possibilities way faster than reality can confirm them with evidence. And the multiverse currently lives right in that gap between a possible explanation and a confirmed fact. So honestly, the hardest part of the multiverse isn't imagining it. The hardest part is testing it. Science absolutely works best when a theory makes actual contact with observation. If a theory never touches the measurable world in any way, it becomes incredibly hard to separate from mere storytelling. Now, that doesn't make it instantly false, but the burden of proof becomes, well, incredibly high.
All right, moving on to our next section, the physics of the multiverse. Now that we have our toolkit and our definitions locked in, what in the world of physics actually suggests a multiverse might exist? It doesn't come from one dramatic aha discovery, but rather from a few very deep theories that naturally point beyond our isolated universe. Physics actually takes two very distinct routes to get there. First, we have cosmic inflation. This is the idea that the early universe expanded incredibly fast, kind of like a tiny patch of dough puffing up into a giant loaf of bread. Some models suggest this expansion didn't just happen once, but keeps happening in different regions, creating separate, totally isolated bubble universes. Then, on the flip side, you have the quantum realm. Down there, reality behaves like a branching network of probabilities. The many worlds interpretation asks, what if all those quantum outcomes don't just vanish, but actually continue, with each one branching off into its own reality? These are two entirely different physical laws, but they both naturally point beyond just a single universe. Let's ground this with another analogy. Imagine you're looking at a water tap. Step 1, you observe water coming out. That is your visible result. Step 2, you logically infer that there must be a larger, unseen network of pipes, valves, and pressure systems behind the wall making that happen. Step 3, you ask if that massive hidden plumbing system has more than one endpoint. Like maybe there are thousands of other taps connected to that exact same source. Physics uses this exact same reasoning. We observe our universe, we infer the massive machinery behind it, and then we ask if that machine produces more than one output. But, and this is a big but, we have to be extremely careful with how we evaluate these theories. When a physicist says a theory implies a multiverse, we always have to ask, is it a strong consequence, where the math literally almost forces the idea to be true? Is it a natural extension, where it just fits the theory nicely? Or is it a speculative reading, where it's possible, sure, but far from settled? A lot of public confusion happens because a scientist will say a theory could imply many universes, and a listener hears, oh wow, many universes are now proven fact. And that brings us to our final section, changing how we think. This is really the ultimate payoff of this entire explainer, because understanding the multiverse isn't just about memorizing some complex physics theories. It's about making a massive conceptual shift in how we view reality itself. The big shift is this. We have to start treating our universe as an open case instead of a given fact. Most of us, we just assume the universe we see is the absolute entirety of existence. But this framework gives us a really powerful intellectual upgrade. We stop assuming our visible patch is the whole ocean, and we start seeing our universe as potentially just one single instance of a much larger, unseen rule. This builds a completely new perspective. The old view always asked what happens inside our universe. It keeps us entirely inside the box. But the new view asks, what kind of larger theory generates a universe like ours at all? Would it generate one or many? We are no longer just studying the contents of the box, guys. We're studying the box itself and the factory that might have built it. Which naturally leads us to a truly profound mystery. Because once you see how physics can point toward a multiverse, the next question is completely unavoidable. If there could be a vast landscape of many universes, all with totally different rules and different outcomes, why does ours look so incredibly finely suited for structure, for stars, and for life? It's a question that takes us right to the very edge of science and philosophy, and it really leaves us looking up at the night sky with a whole new sense of awe. Think about that the next time you look up at the stars.